Frequency distributions are valuable in statistics because they help us to present our data in a compact way. Now, as we all know, frequency distributions may be ungrouped or grouped. Ungrouped frequency distributions are easy to construct and super useful in summarizing data, but sometimes, depending on the type of data that we have, ungrouped frequency distributions may not summarize the data well. This is where group frequency distributions come in to help further summarize the data for easier presentation and understanding. Students and researchers often find it difficult to group data because they don't know the best number of groups to have when doing this. In this video, we are going to focus on how to determine the best number of groups or classes for a group frequency distribution using one of the very famous rules in statistics called the Sturges Rule. The first and the most important step in the creation of group frequency distribution is choosing the correct number of classes or groups. Though there is no hard and fast rule, to determine the number of classes usually denoted as K in statistics, we apply the Sturges Rule. And we do this for uniformity as well as ease of setup. The Sturges Rule is based on the Sturges formula, which is given by K is equal to 1 plus 3.322 times the log of n, where K is the desired number of classes and n is the number of observations. So looking at this data set of the duration of labor from a sample of 40 women who were admitted into the labor ward of Ahmadu Bello University Teaching Hospital, Zaria, Nigeria. If we want to group this data to further summarize it, we will need to first know how many groups will be optimum, and we can do this by applying the Sturges formula. K is equal to 1 plus 3.3322 times the log of n. As mentioned earlier, K is the desired number of groups or classes, where n here is the number of observations, which is equal to 40. So we will just plug this into the formula. K is equal to 1 plus 3.322 multiplied by the log of 40. So just whip out your calculator. Log of 40 is 1.6. So putting that back into the formula, K will be equal to 1 plus 3.322 times 1.6. Now remember your board mass or PEMDAS, right? Multiplication first before addition. So we'll say 3.322 multiplied by 1.6, and this will give us 5.322. Thus we'll have now K will be equal to 1 plus 5.322 and K will be equal to 6.322. We will then round to the nearest whole number, and finally we'll have 6 groups or 6 classes. So when we want to construct a grouped frequency table with this data, we are guided by this rule to have about 6 groups. Awesome, right? Please note that the Sturges Rule should not be regarded as ultimate, but we can use this as a guide. Now, here's a quick exercise for you. Look at this data and quickly tell me how many groups will best represent this data applying the Sturges Rule. Please put your answers in the comment section below, and please do not ignore this. Do you know that the Sturges Rule has some easier and more accurate alternatives? Check out my next video here to see the different alternatives to the Sturges Rule, or this other video on how to determine the best class interval for your data. If you gain value in this video, don't forget to like, share and subscribe for more videos like this. And as always, thanks for watching.